Hello, my name is Manuel de Jesus Andrade Perez, and I am from 3 Aeronautic Section B, code 046498. What is a gas turbine engine? Turbine engine are based on Newton. They large action reaction. Their life with easy with force is applied to a body of force of given magnitude. It produces but in the opposite direction. A gas turbine, also called a combustion turbine, is a turbo machine that extra energy from a flow of combusted gases. It has a compressor coupled to a turbine and a combustion chamber by both devices.
Hello, Miss. My name is Diana Andrea Arteaga Siciliano. My code is 057118. Among the main components of part of the turbine: engine air, compressor. Its function is to compress the intake air of the pressure indicator for each turbine to introduce it into the combustion chamber. Its design is mainly axial and requires a large number of stages. Its operation consists of pushing the air down each stage of blades by an increasing numbering when working against pressure. It is a process that consumes a lot of energy, raising up to 16% of the energy produced by the turbine. To reduce the power required for process, you can opt for a design what cools the air in intermediate stage. Favorite its compressions at a total. It reduces the efficiency of the turbine to the colder entry of the combustion chambers. The higher the combustion temperature, the greater the power that we can develop in our turbine. That is why the design of the combustion chambers is focused on supporting maximum temperatures higher than 1000 degrees centigrade. The means of ceramic coating at the same time it prevents the heat produced from damaging other parts of the turbine that are not designed to withstand shocks. High temperatures they are designed by means of a double chamber. Inner chamber, the fuel mixture is produced through the injectors and the auxiliary, which sorbent and accessed it through distributors from the outer chamber in three phases. In the first, the mixture with the fuel and its combustion is carried out by means of a pilot flame. In the subsequent step, a greater quantity of air is introduced to ensure complete combustion, and finally, before the gas exits to the full turbine, expansion introduces the rest of the compressed air to cool the exhaust gas and not damage the structure and downstream equipment. Exterior chambers, it is responsibility for collection the oxidizer air coming from the compressor. Circulation is the around the exterior of the interior chambers to cool the ceramic panels and the same time distributing the air intake to the interior chamber correctly. Expansion turbine, it is a designed to take advantage of the exhaust velocity of the combustion gas and convert air kinetic energy into rotational mechanical energy. All its stages are there for reactivity and most generate enough energy to power the compressor and the production of the electrical energy in the generator. It is usually made up of 4 of 5 stages, each one made up of a crown of belts with a subcell aerodynamic design which are responsible for turning the rotor to the which they are coupling attached. In addition to the shield, there is before each stage a set of fixed blades attached to the casing and wound mixing is to radiate the exhaust are from the combustion chambers and from each stage in the appropriate directional to the next. The blades must be covered with ceramic material to withstand the high temperatures. In addition, a flow of cooling are from the compressor patient touring the internally, leaving the outside touring small holes made along their interior surface.
My name is Pamela Giron. My code is 056409. I'm 3rd Aeronautical Section B. I am going to talking about Brayton cycle. The Brayton cycle is a cyclical process generally associated with a gas turbine, like other internal combustion power cycles. The Brayton cycle is an open system. Although a thermodynamic, it is convenient to assume that exhaust gases are reduced in the intake, allowing the analysis as a closed system. A Brayton engine is made up of 3 components: a compressor, a burner or combustion chamber, and a turbine. The process of the Brayton cycle is admission. Cool air at atmospheric pressure enters the turbine mouth. Compression. The air is compressed and directed towards the combustion chamber by means of a compressor driven by the turbine. Since this phase is very fast, it is modeled by adiabatic compression. Combustion chamber. In the chamber, the air is heated by the combustion of kerosene. Since the chamber is open, the air can expand, so the heating is modeled as isobaric process. Turbine. The hot air passes through the turbine, which it moves. In this step, the air expands and cools rapidly, which is described by an adiabatic expansion. Escape. Finally, the cool air but at temperature higher than the initial ones goes outside. Technically, is an open cycle since the air that escapes is not the same that enters through the mouth of the turbine, but sign is thus enter in the same quantity and at the same pressure. The approximation is made of assuming a recirculation. In this model, the exhaust air simply transfers heat to the environment and re-enters the cold mode. In the PV diagram, this corresponds to a constant pressure cooling. In fact, there are gas turbine engines in which the fluid effectively recirculates and only the heat is transferred to the environment. For these engines, the ideal Brayton cycle model is more approximate than for open cycle ones.
Hello teacher, my name is David Orlando Piñate Cuellar with code 013018 from third year of Aeronautics Section B. So I'm going to talk about from the engine CFM 56 and 5B. Okay, CFM International is a union of companies between Sigma, France, and General Electric Aviation. Use both companies are responsible for producing various components with their own assembly lines. Okay, General Electric is responsible for the high pressure compressor, for the combustion chamber, and the high pressure turbine. While Sigma is responsible for the fan, the low pressure turbine, and accessory valves and coke. The engines are assembled by General Electric in Embeddable, Ohio, United States, and by Sigma in Villa Rouge in France. The engine is also of the option in the Airbus A320 family. The CFM56 is a high bypass turbo turbofan motor, and with several variants having bypass rotation ranging from 5 to 1 and 6 to 1, generating 18,534,000 pounds per square inch. Combustor. Most variants of the CFM56 have a single annular combustor. An annular combustor is a continuous ring into which fuel is injected into the airflow and igniting, raising the pressure and temperature of the load. This is a contrast to Kenneth combustion chamber, where each combustion chamber is separate, and cannular combustor that are hybrid of the two. So compressor is the high pressure compressor HPC, which was at the center of the original controversial export featured 9-stage on all variants of the CFM56. The compressor stage have been developed from General Electric and General Electric 129 core. That was designed on a compact core motor. The small space of the compressor radius means that the whole engine could be lighter and smaller. Since the accessory units of the system bearing systems could be fused to the fueling system to run in a fuel escape. CFMA tested both the mixed and unmixed exterior design at the beginning of development. Most engine variants have been fan and booster. The CFM56 features a single-stage fan, and most variants have a three-stage booster of the low-pressure shaft. With four stage on the 5B and 5C variants, the booster is also commonly called to low pressure compressor or LPC. LPC it sits on the low pressure shaft and compressors the flow interval before the high pressure compressor arrives. The turbo inverter. The CFM56 designed to support various reverse thrust systems that help to low and down and stop the aircraft after landing. Variants both for the Boeing 737, the CFM56-3 and the -7 use a cascade type of the true reversed. And finally, turbine. All variants of the CFM feature a single-stage high-pressure turbine (HPT). In some variants, the HPT blades are adult single crystal superalloy, giving them high straight and creep resistance.
Hi teacher, my name is Kevin Ivan Carvajal Buendia from the third RB. My code is 015918 and I'm going to talking about from the ARA 72. The ARA 100 contains the reference to the ARA numbering system, which is a common reference standard for commercial aircraft documentation. This commonality allows for greater ease of learning and understanding for pilots, aircraft maintenance technicians, and engineers. The standard numbering system was published by the Air Transport Association on June 1st, 1976. Although the ARA 100 numbering system has been suppressed, it continued to be widely used until it became out of date in 2015, especially in documentation for general aviation aircraft in aircraft fault messages, for troubleshootings and post-flight repairs, electronics, and in printed manuals. It is the unit that provides the rotating energy in the airplane to get the propulsion force given in the propeller and transfer the airplane. Initially, in the model aircraft, this rotating energy was achieved using small sections of rubber thread screwed on before the flight. When returning to the initial position, it provides a rotating energy, fulfilling the function of the two engines. As the years passed, the real revolution occurred in the model airplane sector, producing the appearance of the explosion engine, thus improving and obtaining permanent propulsion. That unit and components that are used to induce the and convert the fluid-air mixture into energy, and the transmission power for the propeller shaft and accessory units. For reports related to reducing gear, combination gearbox, propeller drive shaft, and helicopter rotor shaft, which are used to transfer power from turboprop and turboshaft engines to the propeller or rotor and of a helicopter. Do not use this code for accessory devices connected to reduction gearbox. Typical parts are the shaft, gear, bearing, case, torque piston, transfer tube, chip detector, etc.
Hello, my name is Jorge Vasquez. I am from Third Aeronautics Section B. My ID is 037917. So I told you about the ATA-22 that are divided into 10 sections. So some of these have their definition. So the first is the 7200, that is engine, turbine, or turboprop. The 7210, that is the turbine motor jet reduction. The 7220, the inlet air section, that is the engine section through which air enters the compressor section. The 7230, the engine compressor. That is the engine section where the incoming air is compressed. The 7240, the engine combustion. That is the section of the engine in which fuel and air mix and burn. The 2250, the turbine section. This is the engine section that contains the turbine, disc, and nozzles, and the associated case. The 7260, that is the accessory unit. The 7261, that is the engine oil system. That is the system components and parts that provide lubricating, oil pressure, circulation, and compaction throughout the engine. The 7270, the turbine bypass, for the non-rotating part of the airflow duct engine for the main purpose of adding engine thrust of turbojet engines. And the last one is the 7287, the system cabling.